Hello, I'm Dan Umbach with Movimento. This is our demonstration car, which we use to show our remote over-the-air update. Today we're going to update the engine control module, the PCM, and a portion of our instrument cluster on this vehicle. It's a Ford Fusion Energy Hybrid. We picked this car because it has the sort of the maximum content and the state-of-the-art for vehicles today. We also wanted a nice sedan, and it's quite fun to drive. In our vehicle, we're going to use our Venturo device to be the bridge for the connected car. It allows us to receive information about what needs to be placed into the car and then also report the status of whether the update worked correctly. In order to connect our Venturo into this car, we made use of what we call the SDLC. The SDLC is a gateway that's part of the production environment that supports the OBD2 connector for diagnostics at the dealerships. It also provides access to the vehicle networking. In order to wire our car in, we modified production SDLC to give us our device, the Venturo, access to all of the internal CAN networks. We also have our Premio iOS app. This app is showing what can be done in terms of vehicle knowledge management, in terms of knowing the state of the vehicle as it is today, be able to show the progress of whether there's updates available for this vehicle, and show whether the update is completed successfully. So it shows a representative stock photo of our car, shows our information about our vehicle, and I'm going to initiate the process of seeing if there's an update for this vehicle by pressing the button here. I'm going to enter my security code. So the Venturo has been notified. In a moment, we'll see that the Venturo has received the information and will be able to start inquiring of the vehicle what is going on and reporting that information up. What we're doing here is the Venturo app has received the notification from the iOS app through our Novolo server. And it says that we need to check the vehicle for potential updates, receive the information from reading the DIDs about the modules in the car, put it into a format that we call an iLog or an XML file to communicate to the server the status of the vehicle. In reply to that, we'll receive a manifest or a list of things that need to change on this vehicle. And that'll let us know that there's two modules for this vehicle that need to be updated, the PCM and the IPC. When I look at my iPod app, it will show me that I am downloading my files. It's going to download both the bootloader and the executable files that need to be updated for both modules. As it downloads these files, it shows me a progress bar telling me how far along I am in this process. For our communications, we're using a Wi-Fi connection from our garage. We know that there's likely going to be many different ways of doing connections in the vehicle. Some OEMs like to do a bring your own device. Some OEMs already have hotspots and other connectivities present in the vehicle. The focus of this is that the Venturo box can leverage those different connection technologies to bring the download patches to the vehicle and report the status of the work. As we're communicating up on our iPod screen, we see a list of the modules that are present within this vehicle that we're able to access and interrogate the state of. And once we receive the information from the manifest that says these are the two modules needed to update, we show that information to the user. There's two orange boxes now that show which modules need to be an update applied to them. We can also show the serial number of the modules and the version of the software for diagnostic information. At this point, the car is sort of waiting. The Venturo knows that there's updates available, and it's waiting for the user, the driver, to say, this is a safe time to perform this update. So I'm going to indicate that by clicking the Perform Update. It says that Venturo has been notified. Now it's preparing to flash. There'll be a few things that you'll see change in the car when this occurs. Right now, the radio just went off, the audio stopped, and the screen went dark. And you'll see that the heads-up display on this particular car is flashing. This is a side effect of the diagnostics mode and the programming mode of the vehicle going into it. Movimento has spent quite a few times over the years perfecting the way that we update vehicles as part of our Altero process. The way we execute these reflashes today is with a Puma. It's a handheld device that simplifies what the same process that happens in dealerships, where we're able to sort of put into place the rules for updating the modules into an executable program that exists within this device. We've leveraged that technology we've developed over the years to put into the Venturo box, which we're using to update this vehicle. So it's an extension of our past experience with updating in parking lots and factories, to apply it to being able to update an individual vehicle without having someone go visit the vehicle. An interesting part of the features of this technology is we use Venturo as the bridge to the connected vehicle, and we also use the Premio iOS app as the view into the vehicle knowledge management. Behind the scenes, there's a Movimento server. And the Movimento server is sort of quietly synchronizing the information from the vehicle with the app. And that allows us to not only show it on a screen like this, which was representing what it would look like if it was in the vehicle, part of the IVI system, but we can also have that app loaded on our iPad or our iPhone and be able to see the same information. And so let's say, for example, that we were doing this and we started this process and we needed to go inside to take care of something. We could still view the process of what was going on. In this particular demonstration, the reflash process is relatively short, about 5 to 10 minutes. Some of the more substantial updates can take significantly longer as we deliver more content to the vehicle. Some features of the app is communicating to us our progress, how much of the update has been completed. Since we're updating 2 modules, the first module will be done at about 50%, and the second module will take us all the way to 100. We indicate which ones we're operating on, and the vehicle is stationary. For security purposes, we do not want to be updating the vehicle while it is moving. Part of that's because we're updating the engine control module itself and the instrument cluster, things integral to the functioning of the device. Some other things that I would like to point out is the aspects of security and reliability. As I said, we're leveraging the technology in this system to be able to replicate what we do today in parking lots, reflashes, and in the factory setting. So we've worked through how to handle restarts, battery failures, different things, and keeping track of our initialization files so that we're robust to those issues. We also have an ability to retry multiple times if a module is interrupted and is not able to continue. In the slight chance that it can't complete all the way, we can report out to the Movimento server the success or failure of the update so that the vehicle is not stranded. There is a notification up and action can be taken. At the end of this process, we will be conducting an initial vehicle state, a final vehicle state, and then whatever work was done. And we report this up to the back-end system to be able to close out that work ticket. So there was an action that says we need to update it, and here's the positive response that that work's been completed. A moment ago, I heard the chimes in the vehicle, and the lights on the back and the front of the vehicle flashed temporarily. That was at the end of the first module programming, and that was indicating that that module's image has been applied, power has been restored to it, and allows it to check its application code to make sure it's correct and complete. One of the other features of this system is that we're able to monitor the diagnostics trouble codes, the DTCs, that are put out by these modules and the other modules within the car. So at the end of this reflash process, we can accurately report the state, not only the modules that were updated, but the other trouble codes that may or may not pop up from this action on the rest of the vehicle. There's a second chime, and our second module has now been completed. We're at 100%. This is the time when we do our final query. So we're going back out, we're checking the DIDs of the modules, making sure that nothing has changed. We're also checking the DTCs to make sure there's no trouble codes. Often in our reflash campaigns, the OEM or the Tier 1 has requested that we clear the trouble codes. So we read them, we make sure that they're there, we do a clear, we wait a period of time, see if any others come up, so that when the vehicle is complete, we know that it's in a clean state and ready for operation. So vehicle update's complete, and now we show 2 green check marks showing completion. We're 100% done. This information shows up because the Venturo, the bridge, has communicated the XML file showing the status up to the Movimento server, and then this app is able to read that information and see that that information has truly changed. Now the vehicle is up and running. The radio is going through its initialization process. Our IPC is up. We're now ready to drive away. Thank you very much for your time. This concludes our demonstration.